Hi, I'm Doug Addleman. Today I want to tell you about some work that I did with my postdoctoral advisor, AddlemanStoermer, on how long-term selection history can persistently enhance and suppress visual features. There's a lot of work showing that goal-driven attention can enhance and suppress specific visual features like the color red. There's also more recent work showing that extensive experience avoiding distractors, like salient color singletons, can also cause a feature general suppression of a range of salient distractors in that dimension. Today, I want to look at whether experience can also induce feature-specific biases, for instance, towards colors that are more often associated with targets or away from colors more often associated with distractors. I'll also look at whether any biases like those that do exist are transient, affecting only a few trials, or durable, lasting for potentially hundreds of trials. I'll do this using a paradigm called probability learning. Participants perform a straightforward visual search task in which they try to identify the orientation of a target C that has its gap on its left or its right. They see 8 Cs per trial, 4 in each of 2 colors. And in our training phase, targets or distractors appear more often in one color, whereas in our testing phase, both targets and distractors appear equally often in every color. So we'll be attempting to induce probability learning in the training phase and assess whether any learning that did occur persists durably into the testing phase. First, I wanted to know whether participants could bias attention towards features that they frequently associated with targets. First, I did this in experiment 1A, in which for each participant, I selected 4 colors 90 degrees apart in a circular color space. Participants saw only 2 of these colors per trial, but throughout the experiment could see any combination of these 4 colors. We also performed a near replication of this in experiment 1B, in which participants saw 12 colors throughout the experiment, 30 degrees apart in this circular space, but again only saw 2 per trial. To induce probability learning, we presented items, specifically targets, most often in one color, for instance purple, yielding 3 conditions: the rich condition, in which the target was purple, the neutral condition, in which purple was absent from the display, and the sparse condition, in which purple was actually the distractor. And so if participants are guiding attention towards this high probability target color, they should be fastest in the rich condition, slowest in the sparse condition, and somewhere in between in the neutral condition. And specifically, we made 75% of training trials contain targets in that high probability color, and we had all colors equally likely to be targets in the testing phase. We did the same thing in experiment 1B as well. So what did we find? Here I'm plotting response time as a function of training and testing phase, as well as the condition, rich, neutral, or sparse, that the trial was. And so in experiment 1A, we find evidence suggesting that participants were fastest on rich trials, slowest on sparse trials, and in between on neutral trials. And because this was true in both training and testing, this is consistent with the hypothesis that participants are durably biasing attention towards that high probability target color. We replicated this in experiment 1B, suggesting again that participants are able to guide attention towards the color that's most frequently associated with the targets, yielding fastest responses in the rich condition. I wanted to also know whether participants can bias attention away from specific features by making those features more likely associated with distractors. Again, I used 2 very similar paradigms, one using 4 colors per participant and one using 12. And the paradigm as far as the rich, neutral, and sparse conditions is relatively similar as well. By presenting distractors more often in one color per participant, this yields a rich condition in which that color appears as the distractor, a neutral condition in which that color is absent, and finally a sparse condition in which that color is actually the target. So we have the same predictions if people are biasing attention away from this color. They should be fastest in the rich condition because they're biasing attention away from the distractors, slowest in the sparse condition because they're biasing attention away from the target. We use the same probability distributions only for distractors rather than targets. So what we found in experiment 2A was almost exactly the same pattern of results as we did for the learned enhancement case. Participants were fastest in the rich condition, slowest in the sparse condition, and in between in the neutral condition. And this was true both in training and in testing. And so what this suggests is that participants are guiding attention away from this color that they associate with distractors. And we found roughly the same pattern of results in experiment 2b, although this effect is much smaller there for reasons that we're still actively exploring, suggesting again that there's some durable suppression of this high probability distractor color. And so overall, what we show is that experience-driven attention can persistently enhance features that are associated with targets, as well as suppress features associated with distractors, and that this happens in a feature-specific rather than merely feature-general way. I want to thank you all for your time, as well as thank my advisor, Viola Sturmer, and our funding sources, and I encourage any of you who may have questions or comments to stop by my live poster session on Sunday at 8 a.m. Eastern. Thank you.